Welcome to today's teleconference session. Today we are going to take up one of the important topics in MLIS, that is digital preservation. Today we have with us in the studio Dr. Jagdish Arora, Chief Librarian of IIT Delhi. The program is in two parts. In the first session, he will be discussing about major issues and challenges related to digital preservation. And then in the second part, he will be talking about strategies for digital preservation. Now, I request Dr. Arora to start the session, please.
Good evening, Dr. Kanjilal and colleague. I'll be talking about digital preservation. The presentation, like Professor Kanjilal has mentioned, it is in two parts. The first part would deal with major issues and challenges, including metadata information, and the second part would deal with digital preservation strategies. I would say that the librarians are concerned about digital preservation ever since the first computer was introduced in the library, and the products and services of information technology found its way into the libraries. So we have been dealing with the library automation and e-resources in library. We have been migrating and refreshing opaque data records and in-house databases. The librarians have experience of creating databases on CDSISs, WinISs, and they have been migrated from, say, CDSISs to WinISs, from WinISs to WWISs. So this migration is something we have been doing for quite some time, and we are quite acquainted with it. Of course, the difference is that we have been doing this in case of bibliographic records, and now things have changed from bibliographic records to true digital information, where the entire contents are in digital formats. So let us examine what we have been dealing with in the libraries for past about 20-25 years. We have been getting current contents on CDs since mid-80s. That was the first product that came to the libraries. We had book accompanied with 5 1/4 and 3 1/4 floppy disks, and of course 5 1/4 floppy disk is already obsolete. So the library already have the problem in hand about using data that are stored on 5 1/4 floppy disk. CD-ROM, that is once considered or respected for its longevity, are known to dysfunction much faster than expected, and CD-ROM may be phased out completely in favor of its evolved avatar called DVD-ROM, which has greater storage capacity. The libraries are required to ensure long-term accessibility of digital material that are purchased from publishers, aggregator, or that are licensed, or material that is digitized in-house. So digital resources have several advantages over print counterpart. However, preservation is not one of them. We really have to look into the preservation strategy that we can use to ensure longevity of digital data. Risk of loss of data in digital versus physical form is quite greater. It is believed that while quality of digital image produced would improve manifold, the cost and space required for image would reduce drastically, with proportionate increase in capacity of networks to transmit high quality images. But the issue of digital preservation that are relevant now would relevant even in future, and the reason for that is that software are constantly upgraded, the hardware, the storage disk are constantly re-engineered to store more and more spaces. So there are a lot of issues about obsolescence of software, obsolescence of hardware, obsolescence of platforms, and so on. So digital documents are vulnerable to loss because of decay and obsolescence of storage media, obsolescence of hardware on which the software to interpret the data runs, and preserving digital documents may require substantial new investments. Let us define digital preservation. The term digital preservation refers to preservation of materials that are created originally in digital form and that never existed in print or analog forms, also called born digital, as well as those that are converted from legacy documents and artifacts, for example printed documents, pictures, photographs or physical objects, into images using scanners, digital cameras, or other image technology for access and preservation purpose. In other words, digital preservation includes the documents that are born digital as well as those have been converted from analog media to digital media. Why do digital documents need preservation? So the answer for that is traditional libraries are being transformed into hybrid libraries with increased digital collections. The library has in-house digital collection, captured and born digitable, and digital repositories. The library must cater to the preservation requirement and archiving of digital contents, whether acquired through subscription, purchased in digital forms, or converted in-house. So whatever type of collection you have need to be preserved. Long-term preservation of digital information is plagued by short-term media life. The storage media is re-engineered all the time to store more and more data. Obsolescence hardware and software. The hardware and software gets obsolete very fast. Slow read time of old media, and defunct websites. You would have come across several sites that you have once visited, but they are no more available. So it is librarians' prerogative to see that such information that existed in web space one time and that is important to users are preserved. The exponential growth in digital information and its ephemeral nature, as well as considerable challenges associated with ensuring its continued access, necessitate that concerted efforts be made to overcome these challenges. And there are enough evidences that suggest that if timely action is not taken, digital information can be lost forever. There are some data. For example, in 1960, US census on univoc paper tape was done on paper tapes, and that paper tape reader are no longer available. If you want to interpret that data, those tape drives that read paper tape are no longer available. There is another example where NASA, NSF and other agencies rescued 20-year-old TOVC or AVHHR satellite data on global warming. So there was a lot of data collected and that has to be recaptured, and the recapturing of this data took a lot of efforts and time. Land Use and Natural Resources Inventory Project, LUNR project, it was done in New York City, where the local resources, the natural resources of New York City was planted in kind of a geological information system. Now this geographical information system was some kind of a preliminary geographical system done in 1970, and that data is no longer available because it was done on proprietary hardware that no longer exists, and the software that was written was in a language which is not contemporary in nature. So that data is lost forever. Now let us look at challenges for preserving digital contents. What are the major challenges that plagued digital preservation? One of the challenges, dynamical nature of digital content. The digital content themselves is a challenge. Like I gave you an example of website. The websites are consistently changing. The site that you have once visited, you can no longer go. The website themselves are changing. That means digital contents themselves are changing very fast. When the digital contents are changing, how do you preserve them? So it's a basic issue which have to be addressed. For example, one of the study that was done on one of the paper published in ACM Digital Library, it said that 43% of the references given to the websites are no longer available. So that means what you are preserving may not have meaning when it is read 10 years from now. The links that are embedded in a paper are obsolete, are no longer available. Machine dependency, most of the data that are most of the formats in which data is saved are machine dependent. So unless that platform is available, unless that application is available, you cannot reuse that data. For example, the document saved in WordStar cannot be reused unless that application is also available. That application is now obsolete. The WordStar format is obsolete. So unless you have migrated that document into a contemporary format, it cannot be used. So machine dependencies, and machine dependency is specifically applicable for programs. For example, there is a program that is compiled in DBase. it can run only in that environment where you have DOS, where you have DBase, then only it can run. So machine dependency is a important criteria. Fragility of media, the magnetic media, like you said, the floppies, they go bad very fast. So it's very fragile media. Technological obsolescence, the technology obsolete every 6 months. As you know that every 6 months you have a new computer. Although the old computer still works, but then maintaining those old computers and data that are lying on that computer is difficult. Hardware, software and file formats, all of them are upgraded. Hardware, as you know, it changes very fast. Software, you always have new versions of software coming. In fact, some of the software are known to last only for 1 hour. One of the software that was brought out by Google lasted only for few hours. The beta version, the new version came up within 1 hour. File formats are changing very fast. For example, we started using PDF version 3 in 1991, and now we are already in PDF version 7. So versions are changing, and maybe what is coded in PDF version 1 may not be read by version 7 of PDF reader. So file formats are changing very fast. Shorter lifespan of digital media, that we have already discussed. Format and styles that are changing. Copyright and intellectual property right is another big issue. What you have bought from the publisher is a particular format, is a particular style. If you change format, you are touching upon the delicate issue of intellectual property right. So those things have to be addressed properly. Similarly, software also, you have bought it particular version of software. When you want to re-engineer that software so as to read your data, you are playing with the property rights. So those things have to be kept in mind. Let us look at the principle of preservation as applied to digital preservation. Preservation is, I would say, it's a technology or technique that are being used even the traditional analog environment. We have been preserving our printed media, maybe using microfilming technology. We have been preserving our microforms, giving a right environment. So preservation is something which is not new, which is not applicable only to digital media. It is also applicable to analog media. So the basic principles of preservation that are being practiced for preservation of analog media are also applicable to preservation in the digital media. What are those principles? Longevity. Longevity means that you would like your digital contents to be available as long as it is required. It is true in printed media, it is also true in digital media. Selection. Selection is a very important criteria. The libraries, all libraries have a tradition of weeding out what is not required by their user. So selection is applicable in digital media also. You may not like to preserve something which is obsolete, which do not have access value and which is not required by anybody. So weeding, as is applicable in analog media, is also applicable into digital media. So you'll have to weed out what you do not want to preserve. Quality. Quality is important. Quality in terms of digital media include quality of the media that you are digitizing, the quality of analog media that you are digitizing. The quality should be good so that it gives the perfect true replica of analog media. Integrity of document is important. Integrity basically means whatever has been done in analog media should be truly replicated in digital media. And as you know, it is very easy to tamper with digital media. It is easy to change record. It is easy to change data in digital media. It may be done intentionally, or it may be done in the process of transforming data. So integrity is important, and that has to be taken care of. Access is another important criteria when it comes to digital preservation. So when you are talking about digital preservation, what you need to assure is that the material is accessible to those who require it or who need it. Like in traditional media, when you preserve something, it is basically taken off from the open shelves and kept in closed shelf. so that it is protected and preserved. But in digital preservation, access is important. You should provide access, and it is possible to provide access as well as preserve the media. Now let's look at information density and life expectancy of storage media. You would see that we have included media like papyrus, printing material, newspaper, microfiche, disk, optical. And you would see there are two lines. The solid lines talk about years of usage, and the broken line stands for characters per square inch. You would see that while the older media which have lesser density can last for long. For example, papyrus per inch density is only 53 words, but it can be accessible for 5000 years. But if you look at the last one, optical media, where the density has gone to more than 50 million characters, but its longevity is only 5 years. So that is the difference. While the density is going up, the expectancy or the life expectancy is coming down. So this is true for digital media. It has greater storage capacity, but the longevity is really questionable, whether it is CD-ROM or magnetic media or any other storage media. Now let us come at digital preservation metadata. What is metadata? Metadata, as you know, is cataloging information or data about data. Basically cataloging information. When it comes to digital library or digital preservation metadata, we are basically talking of metadata that describes attribute of digital resources essential for its long-term accessibility. It describes and records information needed to manage the preservation of digital resources. It is subset of administrative data that is designed to assist management of technical metadata for continuing access to digital contents. Let us look at what are the kind of digital data that is required to ensure longevity of digital data. Origin source. What is the original source of information, whether it is analog media or is it born digital? Date of capture or creation. Scanning resolution. Scanning resolution is very important. Its scanning resolution may vary from 150 dpi or to 600 dpi. dpi stands for dot per inch. That is how scanning resolution is measured. So scanning resolution, higher it is, better it would be to reproduce in original form. Initial capture settings, version of digital objects, file format. File format is very important. Compression technology used, object relationship. File format, for example, examples of file format could be PDF, TIFF, JPEG, GIF. So this file format and its version is very important. For example, TIFF version 5 is about 2 versions old. TIFF version 7 is the contemporary version. So unless somebody knows what is the format used and the version of format used, it is not possible to convert into contemporary version. Compression technology is very important. Compression technology should be a standard compression technology. When you say that you have saved an image as TIFF, that means you are using technology compression used in TIFF, and the TIFF uses compression technology which is specific to TIFF itself, which is inbuilt into the format itself. When you say that you've saved an image as JPEG, that means you are using JPEG compression technology. Object relationship, that basically means that what are the metadata that describes it, how two objects are related. For example, a document may consist of 15 pages. So object relationship would mean that for 15 pages are related to each other, they are sequentially arranged. Similarly, pictures or graphics that are attached with it should also be described appropriately. Most of administrative and technical metadata can be generated automatically by the hardware and software used for capturing contents. While this is administrative metadata, as you know, the descriptive metadata have to be assigned by manual intervention by librarians using vocabulary control, using thesaurus, using subject headings and other things. But administrative metadata generally can be generated by software that is used for converting analog media into print media, analog media into digital media. The administrative metadata also records legal and financial aspects of access to the object, such as right management, cost, authorization, authentication, etc. Now there is a standard which is called Open Archival Information System, OAIS, that basically describe the kind of metadata that can be used to describe a digital object. It is developed by Consultative Committee for Space Data System. It's a framework for applying concepts needed for long-term digital preservation. It identifies key components and processes important for digital archiving and proposes a model for digital objects and their associated metadata. The reference model does not specify its implementation, but it just basically defines a framework, and it's a ISO standard. This OAIS has been recognized as iOS standards. The type of information needed under OAIS reference model can be grouped under two major categories, that is preservation description information and representative and description information. While preservation description information basically talks about preservation metadata that we've already spoken about, the representation descriptive metadata describe the contents, the subject contents of digital objects. Basically it means that it would describe what are the terms used for retrieving it, what are the subject terminology, what are the major groups and subgroups, and what are the other systems, other retrieval point of bibliographic data used for describing a digital object. The basic framework of OAIS model is given in this diagram, where you can see that there is a system called ingest with the data, descriptive information, as well as analog, the technical information is fed into the system. The ingest takes the data into data management and archival storage, and then it is made accessible to the users. So it's a complete model for digital library, which basically ensures that there are unique identifier for each digital object, and the query raised by the user through access system is retrieved using these unique identifiers. Another project which basically describes the metadata, preservation metadata implementation strategy, is called PREMIS. PREMIS was basically sponsored by OCLC and the Research Library Group to explore and promote implementation of OAIS model. OAIS model, like I said, is a proposed model which do not specify as to how to implement it. PREMIS plays the role of how to implement OAIS model. It defines a core sets of implementable, broadly applicable preservation metadata elements supported by data dictionary. It identifies and evaluates alternate strategies for encoding, storing, managing and exchanging preservation metadata in digital archival systems. The final report of the PREMIS working group was released in May 2005. The PREMIS data dictionary is a comprehensive practical resource for implementing preservation metadata in digital archival system. It defines implementable core preservation metadata along with guidelines and recommendations for management and use. Now I have talked about persistent identifier or open URL. Let us examine what it is. While most of the other things that I have talked about digital preservation you would have come across in your lessons on digital library, but persistent identifier is quite unique to digital library, as well as they are very important for preservation metadata. So a good digital library uses persistent unique identifier instead of using absolute file name and addresses, that is URLs. URL, as you know, are inflicted with the problem of going redundant, or there is a tendency to change the URLs. So to tackle this problem, the proposal is to use persistent identifier or open URL. Unique identification scheme for digital objects utilizes a registry or resolver that map static persistent identifier to the current location of object. However, mapping tables or resolver server must be updated whenever the object is moved. There are 4 kinds of persistent URL. Persistent URL Perl is the one that is supported by OCLC. Handle is supported by CNRI. Digital object identifier is a implementation of handles that are used by publishers, especially publishers that are members of Crossref, and open URL is another technology to achieve the same target. Now if you look at how the resolver are applied, generally speaking, a handle is like you can see in the screen, it shows a DOI handle. The user click at the DOI handle, it goes to a resolver which gives a persistent URL. It basically translates this number into a HTML URL and it sends the user to that particular document. So it basically a translation service. For example, many a time you would have come across some telephone number that are obsolete. When you dial that number, the directory service tells you that this number is obsolete. Now instead of using 4 as prefix, use 2 as a prefix. So you can map this concept with the same. You give a number and that number is translated into the real HTML URL and you finally get to the website. It basically means that it takes care of broken links that you come across when you are using websites. Now let us touch upon storage management for digital preservation. Storage is important, as you know that computers are known for hard disk crashes, for system failures, and for all kind of problems. Now when you have a digital repository which is to be made consistently available to users 24 hours a day, 7 days a week, you have to have solution which provide consistent availability of data to the users. So primary consideration for digital preservation include making the information available in storage media in hierarchical and redundancy way. Multiple levels of storage depending on level of use and retrieval performance. So there are 2 solutions. One is hierarchical and another is redundancy. These are storage solutions. While hierarchical storage mechanism for large digital repository defines that they are consistent fast disk for frequently accessed data and nearline storage for less frequently used data. You would have seen the large digital library with tapes of information available there. Now of course you don't see many of them, but still when that data runs into terabytes, those nearline solutions are essential, where the data that are less frequently used are stored on nearline tape system, whereas the data that is used more frequently are stored on hard disk. So an HSM, that is hierarchical management system, can automatically migrate data from tape to disk and vice versa as required. Digital materials in a distributed network may be stored online in multiple locations. Besides offline and online storage, nearline storage may be adopted, wherein information objects may be stored on optical or tape media and loaded into jukebox. The other component is storage redundancy. Effective storage management provides for redundant copies of the archived object to ensure availability of document in case of loss. This basically means that you have multiple disks. The RAID technology, redundant array of inexpensive disks, basically define that there are multiple disks containing the same data, and if one disk failed, the other disk would start operating immediately. It already have the same data, so a user would not know there is a case of failure. He would start getting access from the second disk, and if the second disk fails, he starts getting access from the third disk. So this is called redundant array of inexpensive disk, which is now used very frequently, especially for digital library applications. So RAID technology distributes the data across a number of disks in a way that even if one or more disks fail, the system would still function while the failed component is replaced later. Digital archives may also choose to make backup copies of their own to make arrangements for other sites to serve as backup. For example, there are several sites. For example, Metadata is a database in mathematics which have 8 sites across the across US and even other countries. So if a user finds problem in getting access from one data, he is directed to other site where he can access Metadata. Similarly, the open archive called Archives, ARXIV, also have multiple sites. A user can approach to any sites. In cases of failure, they already have multiple mirror sites distributed across the countries, across the globe, and that are updated regularly. Although the hard disk, fixed or removable solutions are increasingly available at an affordable cost, optical storage devices including WOM, CD, CD-ROMs, DVD-ROMs or optomagnetic devices in standalone or network mode are attractive alternate for long-term storage of digital information. Now we have talked about storage solution and 2 alternate where you have redundancy and hierarchical storage mechanism. The other important component is microfilming of digital preservation, a hybrid solution. Now, as you know, that digital documents themselves do not have a long span of time. In fact, we have been experimenting with digital documents for now less than about 50 to 80 years. So we do not have a very long-term association or long-term preservation experience with the digital document. So microfilming as an alternative is suggested by several people. So microfilm is a tried and tested technology for preservation of document with proven longevity. The life expectancy of microfilm is more than 500 years old. Microfilm masters, if stored properly, is quite simple and most stable reformatting method available. The hybrid solution suggests that microfilm of document as first step and then digitize from the file master. Now the basic concept is when you take a microfilm, your scanning resolution is more than 1400 dpi, 1400 dpi. But when you scan a document, the scanned document is only 600 dpi. It cannot go beyond 600 dpi considering the technology that exists now. So it is always possible that you take a microfilm first as first step and then take a digital document from the microfilm itself. It is always possible to take 600 dpi from a 1400 dpi document, but reverse is not possible. You cannot take 1400 dpi from 1600 dpi. So on that pretext, this solution is proposed, that you have a hybrid solution where you take a microfilm first or microfilm first and digital document later. Moreover, if you can scan theoretically at a larger DPI, the technology that exists now cannot display a document at a higher resolution. The display technology itself has limitation on displaying the document. So hybrid solution provides the best of both worlds. The high resolution microfilm masters can be safely archived and retrieved when needed to generate new high use, highly accessible digital version. The process also serves to circumvent the problem with digital technology, that is constant migration. The digital technology, as you know, need constant migration. I gave an example of TIFF. Now we are already in TIFF version 7. PDF also is running into version 8 now. So there is a problem of constant migration. The hybrid solution circumvent that problem. The new digital files in successive software generations could be created as required for microfilm masters. So in conclusion, for the first part of presentation, I would say the preservation in digital world is a challenging task for librarians and archivists. Protocols, strategies and technologies involved in digital preservation have now been well defined and understood. Digital preservation is a cost-intensive activity of continuing nature, and digitization with long-term preservation and storage of research collections require deep and continuing commitment by the parent institution. Digital resources undoubtedly have several advantages over its analog counterpart. However, preservation is definitely not one of them. The fact that the risk of loss of data in digital form is much greater than any other physical form, it is well understood and addressed to in preservation strategies. Failure to address to the digital preservation issues may result in loss of valuable digital data, resulting in exorbitant cost for recovery, if at all possible. So this was the first part of presentation. Thank you.
Thank you, Dr. Arora. Now the floor is, questions are welcome from the centers. In the meantime, I'll ask you, Dr. Arora, actually what is the role of librarians in this whole process of digital preservation? If you see, actually, when we were talking about preservation of documents in analog form, we were taking help of archivists and conservators. But when we talk about digital preservation, what kind of role the librarians can play?
Well, see, the difference now is that when you had analog media in your libraries, you had a lot of time to take care of those analog media. For example, the printed books has history of going into hundreds of years. You have a book which is lying with you for hundreds of years. If there is a preservation required, you can do it in 50th year or even 60th year, and even so on. So it's with you, and the time that is available to you to convert into another format is plenty. The microfilm is one technology that has been used. There are other physical technology that basically talks about preserving document itself, of course, where the role of preservationist comes. Digital media, now the difference here is that you are procuring your media, your material in the library in digital form itself, and the time that is available to you is very less. We have witnessed that several storage media have just obsolete. For example, 5 1/4 disk is no more available. The floppy disk that reads that material is not available. So the time shortage is there. So a librarian has to be alert as to when to convert those material, and that converting that material may not be highly technical. You may not really need outside advice or outside help to do that. I mean, when you know that this particular diskette is being phased out, this technology is being phased out, at that time you can convert your document from one storage media to another storage media, from one format to another format. I will take example of Microsoft WordStar I was talking about. WordStar is now obsolete, and maybe the Word document that you had in WordStar. In between, you would have seen that packages like Microsoft Word or packages like WordPerfect would read a Microsoft Word, a WordStar file and convert it for you into a WordPerfect file or into Microsoft Word file. So the earlier version had given you the possibility of converting a format into another which is more contemporary in nature. Even I'll take you another example. For example, Microsoft Word. If you read a Microsoft Word file generated in 95 or using Microsoft Word 95, now it gives you an option that you can now save it in the Microsoft Word 2002 version. So those things are now available. Of course, if you have those 5 1/4 disk which is now obsolete, now you will definitely need outside advice to convert into the format which is contemporary now. So I would say in nutshell that the problem now is that library themselves are getting a lot of digital material and time to convert them is very less. That is why, and the techniques that are available is some that you can use without outside expertise if it is used timely.
Yeah, that's right. In fact, when we are teaching preservation of library material, we talk about, in fact, that for any library document, in fact, we have to see the three important aspects, that is the artifact, the image and the information.
Right.
So in fact, when we were talking about preservation from the analog point of view, it was more on the preservation of the artifact and the preservation of the image.
Right.
But in fact, when we talk about preserving the information, there is the actual role comes when we are transferring the material from the analog form to the digital form. And
Right.
in fact, that's a major issue that, I mean, like, we have to also make a decision that are we really going to store the image, the artifact, or we are more interested in the information part. So a sort of a decision has to be taken by the librarian. In case of manuscripts and all, the artifact is important, which we need to preserve. Whereas when we talk about books and periodical articles and all, in that case it is the information content that we are more interested in.
Right.
Now again, coming to this, as I was mentioning about periodical articles and all those things, in fact, if we look into, at the moment when we talk about digital libraries, what we see presently, it's we are dependent more on to the licensed born digital material. Now, where we may not even have perpetual right to access, it's based on the period of license that we have subscribed to. Then where does the question of, I mean, that persistent identifier and all those things come in?
Right.
And where is the point of digital preservation?
Yeah, I absolutely agree with you that when you are not the owner of content, you cannot take the responsibility of preserving something that is not your own. You have just licensed it to use. Now that is where your role as a librarian comes, that you should be very clear as to what you are getting into. Sometimes librarian may not know that they are signing a license document that gives access to the contents for a specified period of time without perpetual access built into it. So what librarian should be able to do is very clearly see whether the perpetual access is available or not. So the best a librarian can do in such scenarios is that he should look for material that are available to him on perpetual basis, and the responsibility of preservation falls onto the publisher, not onto the librarian. But of course there are several initiatives like JSTOR, like Potrica. So those particular initiatives ensure that even if the publisher do not support long-term preservation of material, these products like JSTOR and Potrica, they do support long-term preservation. So librarian should be able to see as to a publisher has signed up with these kind of initiatives or not. There are several others which do look into those concepts. So I agree with you that librarian cannot take the responsibility of preserving material that are not their copyright or they are not, which are not sold to them. But of course, you can see that publisher has taken care of digital preservation.
Before we wind up, maybe a quick answer about the best format that you will suggest for the material to be stored in, and also the media that is to be used.
Okay. Coming to the formats, there are formats that are called de facto standards. For example, when you talk of black and white bitonal images, de facto standard is TIFF, which is non-proprietary and which is available in public domain, used very widely, and that is why it is a de facto standard. So in other words, you can say that the format that are being used very widely are likely to be supported. For example, PDF. PDF is not it's a proprietary standard, but the PDF readers are available on all platform. It is available very widely. So PDF is a de facto standard for distribution of electronic documents. So
Thank
PDF
you.
Is a format. So I would say that.
Thank you very much. Actually, we'll resume our discussion after at 6 o'clock again in the next session. With this, we end our presentation. Thank you.
Thank you.